Good morning to everyone. Madam, you can hear me? Hello? Hello,
Yes, sir,
madam?
I'm hearing. Yeah, yeah,
Okay. We start
it's
now.
audible.
Yeah,
We can.
okay.
Yes.
So my
Yes, sir.
student is,
Everything,
yeah. So
sir.
whatever doubt.
Everything is fine. Everything is fine,
Okay,
sir.
sir. Thank you.
We
Thank
can
you,
see
sir.
your PPT. Yeah. Okay, thank you,
Okay,
sir.
yeah. So today I'm going to take only a very small portion, and the portion in the sense very small concept. So it's not a very big deal. So that concept is called the association rule mining, and at the same time it's a subtopic is we have one subtopic. So that is called a collaborative filtering. So these two concepts we are going to deal today in this class. So first we have to discuss what is association rule mining and what are the application for this association rule mining. It's a very small and a simple topic. So here, what is the meaning of an association rule mining? Why this topic is important? So association rule mining find interesting association and relationship among large set of data set. These rules show how frequently an item set occur in a transaction. A typical example is market-based analysis. It allows retailers to identify relationship between the items that people buy together frequently. So here it's a very simple. What exactly an association rule mining or what is the meaning of association rule mining? So here, for example, some items are highly correlated. A very simple example in market based analysis, the person those who are purchasing sugar, the chances for purchasing coffee powder or a tea powder is very high. So these two items having more correlation and highly associated. So you have to find such a relationship. What is the importance of finding such a relationship? In general, in data mining concept, once you are able to find those relationships, attributes among the attributes, so if you are able to find such a relationship, then mining the data will be easy. The reason is here you can reduce the number of attributes, the number of rules which we are generating in associate rule mining is purely based on the number of attributes. So here you are reducing the number of attributes or the combination of the attributes, number of rules will reduce and easily you can retrieve the information. So that is the importance of associate rule mining. So that is the reason we are introducing this associate rule mining in this concept into data mining. Yeah, so that is the basic idea behind the associate rule mining. So I think this is clear. So show frequently an items occurs in a transaction, typically example in market-based analysis. Go to the next slide. So here, what is the formal definition of associate rules? Let I is a set of n binary attributes called items. Okay, items. Item number 1, item number 2, item number 3, etc. up to item number n, whatever may be the items. Then in market analysis, these items are some product. Okay, in a real-time systems, these items may be in terms of features or attributes, whatever may be. Yeah, and D is be a set of transaction is called a database. So here we may have some transactions. So that is what is called D here. Now in each transaction in D, as a unique transaction ID. So each and every transaction, even in a market, or you're going to a supermarket or wherever you'll go, and you will purchase some items, and you will get a unique ID. That means you will get a bill. In that bill, you have a unique ID. So that's what here they were mentioned. Each transaction in D has a unique transaction ID and contain a subset of the items in I. Okay, subset of items. Now, the rule is defined as an implication of the form X implies Y, where X, Y, okay, X and Y, okay, here X and Y are some items. Okay, X and Y's. A set of items X, Y are called antecedents and consequence of the rule respectively. So here, rule-based systems, associate rule mining is also one type of rule-based systems. The rule-based system is purely based on antecedents and consequences. So what is the meaning of antecedents and consequences? Antecedents in the sense if-then statement. Means if this is happening, then this will happen. Okay, for example, it's antecedents, you failed one paper once in one semester. What is the consequence? You failed that subject, that is one consequence, and you failed in that particular semester. So that is the consequence, if then. So that antecedents and consequence in general rule mining systems are single antecedents and single consequence, single antecedents and multiple consequence, multiple antecedents and single consequence, multiple antecedents and multiple consequences. So here associate rule mining system also one type of antecedents and consequences. Antecedents and consequences. Yeah. Up to this point, clear? Any doubt from any side, please? Any doubt? Any doubt? If we can ask me, please. Associate rule mining. So this is the concept or this formal definition of associate rule mining. Now, learning of associate rule is used to find relationship between attributes in large data set. So you may have different attributes in terms of machine learning. You may have different attributes. So you have to find what type of, whether those attributes is having any relationship or what type of relationship is exists between those attributes. Then we can club together those attributes and we can reduce the number of rules in your entire database system. That's the reason this associate rule mining we are using. Yeah. Learning of associate rules is used to find relationship between attributes in large database. An association rule, A implies B, will be of the form for a set of transactions. Some value of item set A determines the value of item set B under the condition in which minimum support and confidence are met. So here associate rule mining, two terms are very important. So those two terms are called support and confident. These are the two terms associated with associate rule mining. So here it is, an associate rule, A implies B, will be of the form for a set of transactions. Some values of item A determines the values of the item B under the condition in which minimum support and confidence are met. So here, these 2 points are very important. So we have to define what we mean by minimum support and confidence in associate rule mining. Yeah. Now, what do you mean by minimum support and confident, or support and confident for an associate rule mining? So here we can see that a support equal to the number of transactions in which A appears for a particular item is appear. Okay, A is the number of transactions in a particular item is appears divided by the total number of transactions. Okay, so that means maybe you may have a 10 transaction 10 transactions, you may have a 10 transactions. From that, for a particular items, 7 times that is appearing. Okay, so the support is 7 by 10. Totally you have a, just assume that in a transaction number 1, item number 1, item number 2, item number 3. Transaction number 2 maybe item number 1, item number 3, item number 4, etc. Like that you may have a 10 transaction. Now just assume that, okay, item number 1 is present in 7 transactions out of this 10. So that 7 by 10 is called a support of A. So that is the basic definition of support. Number of transactions in which A appears, the total number of transactions. Now here, the confident A implies B is support of A union B. So that means you have to calculate the support of A and you have to calculate the support of B. Then from that A union B, in the sense you have to take the maximum of A and B divided by support of A. So that is called a confident. So these two terms are very important for a associate rule mining. So I think these 2 points are clear. And any doubt regarding up to this point, you can ask me. Otherwise, we'll go to the next question. Yeah. Any doubt or clarification up to this point, please? Okay, I think there's no doubt. So now we understood what is the meaning of associate rule mining and what are the terms support and confident. Now, based on this, we are going to introduce one small algorithm. So that algorithm is called a priori algorithm for frequent pattern algorithms. Okay, for a frequent pattern algorithms. So we'll see that how this a priori algorithm will work and how we can apply or how this a priori algorithm is reducing the number of rules and how this algorithm is going to support extract information with a minimal time. Yeah. So here a priori algorithm is that we have a data set of items, item set. Now you have to generate k item set. I'll explain with one example. K item set. Then you have to check the support. Then the some item set the value of the support is less than the cutoff value. Then you have to prune and you have to throw that one. Then okay, then free. Now you can take the next frequency items. Then set okay, you have to decrement k, that is k to k minus 1. Okay, and item to 5. That means it's like k equal to 1, k equal to 2, k3 equal to 3, etc. At last, we are going to stop. And from that at relationship, you are going to find the rules. So that's what this a priori algorithm is doing. So I'll explain with one example how a priori algorithm will work. So here we can see that we have totally 6 transactions. Transaction number 1, that is T1, transaction number 2, transaction number 3, transaction number 4, transaction number 5, and transaction number 6. These are the 6 transactions, and we have items. This item number 1, that may be sugar. Item number 2, that may be uh, tea powder, and item number 3, that may be biscuit. So for a first transaction, these are the 3 items they were purchased. And for the second iteration, second transaction, we can see that from the first item number 2 and item number 3 is present, and item number 1 is not present, but a new item is called item number 4. Now we can see that T3 is there is no item, so only item number 4 is present, and a new item is called item number 5. And for a transaction for 3 items, item number 1, item number 2, and item number 4. Transaction 5, item number 1, 2, 3, and 5. Transaction 6, item number 1, 2, 3, and 4. Now these are the basic data set we have. Now in this particular example, these items, okay, in these items may be features, or these items may be some items in the sense some sugar product, whatever may be. Okay. Now here you have to fix what is the minimum support and the confidence you are going to provide in this particular scenario. So here I was mentioned that the support is 50% and confidence we are fixing it as 60% initially. Okay, the support of threshold is 50%. So here we have a 6 transactions. So support threshold you are going to fix it as 50% of 6 transaction, that is 3. So now we fixed the minimum support as 3 and confidence is 60%. Okay, support is 50, we are fixing initially, and then confidence is 60%. In this particular problem, totally we have 6 transactions, and 6 into 50% of 6, that is 3. So that we fix it here. So minimum support is 3 now. Now, what we are going to do? We are going to do like, okay, first we are going to take, because totally we have 5 items. First, we are going to take each and every items independently. So that means item number 1, item number 2, item number 3, item number 4, and item number 5. Then we can go to the database. Item number 1, we can see that item number 1 is present in transaction 1, item number 1 is present in transaction 4, and item number 1 is present in transaction 5, and item number 1 is present in transaction 6. So that means totally 1, 2, 3, 4. So here I have written item number 1 equal to 4. Now go to the database again. We can see the item number 2. Item number 2 is present in first transaction, second transaction, third transaction, first transaction, second, fourth, fifth, and sixth. Totally 5. So here I written T2 L2 as 5. Such a way we can calculate I3 or L3, it is 4, I4 that is 4, and I5 you can see that in I5, item number 5, item number is 5 only in 2 position. One is transaction 3 and another one is transaction 5. Okay, now this is the frequency table for independent items. That means only one items. Now what we are going to do, you have to check, we fixed that the minimum support for this particular problem is 3. Now you have to prune, in the sense, now the support is 3, but here we can see that one item is present only, item number 5 is present only 2 times. So this item number 5 or the feature 5, we can say it as a feature 5 or item number 5 you can throw. The reason is this is below to the threshold. So now you can throw that item number 5 from this, and this is the pruned set. Means only 1, 2, 3, 4 items are there. This is the corresponding count or frequency for this particular items. Now, now what we are going to do, you are going to take 2 at a time. So we'll see what are the combinations. So here 2 at a times, item number 1 and item number 2, item number 1 and item number 3, item number 1, item number 4, item number 2, item number 3, item number 1, 2, item number 4, and item number 3, item number 4, etc. Okay, so these are the items. Now what you have to do, 2 at a time. Okay, now again you can go to our data set. Item number 1 and item number 2 combination is present here. Then item number 1 and item number is present in transaction 4. Item number 1 and item number 2 is present in transaction 5. Item number 1 and item number 2 is present in transaction 6. Totally 1, 2, 3, 4. So I1, I2 combination is 4 here. You can see that I1, I2 combination, it is 4. Like that we can see I1 and I3. I1 and I3 in the same data set. So here we can see that I1 and I3 1. Then I1 and I3 1, I1 and I3 1. So I1 and I3 combination is present in 3 times. So here we can see that I1 and I3 is 3 times. And similarly, we have to calculate the next combination I1 and I4. And we found that it's a 2 times it is present. And I2 and I3 4, I2 and I4 is 3, and I3 and I4 is 2. These are the different combinations and the corresponding count. From this, we understood that the maximum, minimum, this one is a 3, support is 3. So here, whatever combination of items, the support is below 3, you have to throw. So here we understood that I1 and I4, the minimum is 2. Then I3 and I4, the minimum is 2. Sorry, this value is 2, but our value is 3. So this 2 is less than 3. So you have to throw this one and you have to throw this I3 and I4 also. Now we can see after performing the pruning, this is the pruned set. I1 and I2, the count is 4. I1 and I3, the count is 3. I1 and I3, I2 and I3, the count is 4. And I2 and I4 is the count is 3. And this is the pruned set. I think up to this point, any doubt you have, you can ask me, please. Now, so initially we were taken one at a time. Now it's a two at a time. And now we can go to the next one is called a 3 at a time. 3 at a time. So here we can see that 3 at a time combinations are I1, I2, I3 is one combination. I1, I2, I4 is another combination. I1, I3, I4 is another one. I2, I3, I4 is a next combination. And we have to see that what about the total number of counts? Okay. What about the total number of counts for each and every items? So here I1, I2 and I3, I1, I2 and I3 is 1, I1, I2 and I3 2, and I1, I2 and I3. So totally here we can see that I1, I2, I3 is present in transaction 1, and I1, I2, I3 is present in transaction 5, and I1, I2, I3 is present in transaction 6 also. Totally 3 places this I1, I2, I3 is present. So that we have to write here. I have written, so I1, I2, I3. Then we have not written, but that is equal to 3, I1, I2, I3. Now we can see what about I1, I2, I4. I1, I2, I4, I1, I2, I4 is present only I1, I2, I4, 2 places. Okay, I1, I2, I4 is present only 2 places, but our minimum support is 3, so that I1, I2, I4 we can throw. Similar way, we can see what about I1, I3 and I4. I1, I3 and I4. I1, I3 and I4 is present only one place. So our minimum support is 3. So you can throw that also. So here, after checking the minimum support, I1, I2, I3, this is 3. I1, I2, I4, that is 1. I1, I3, I4 is 1. And I2, I3, I4 is 1. So totally 4 item sets are there. From this, only one item set you have to select, because only those item set is having the threshold or a support value is 3. All others, the support value is less than 3. So you have to throw these 3. Only you have to consider I1, I2 and I3 is frequent. Only those items you have to consider. All other items are not needed, because this is less than this one. Okay. So now we are taking only I1, I2, I3 data set. Now using this I1, I2 and I3 data set, we are going to form the rules. Yeah, we'll see that. So here we can see that how we are going to form a rule. So here totally we have 3 attributes, I1, I2 and I3. So I already mentioned that how we are forming the rules here. Okay, so this is the way A implies B. This is the way you have to form the rules. So now we'll see how we are going to form the rule. So here we understood that only 3 items are there, item 1, item 2 and item 3. So here we are going to form the rules like item number 1 and item number 2. That means one person is going to purchase item number 1 and item number 2. Surely he is going to purchase item number 3. Then one person is going to purchase item number 1 and item number 3. Then surely he is going to purchase item number 2. Then one person is going to purchase item number 2 and item number 3. Then surely he is going to purchase item number 1. Similarly, one person is going to purchase item number 1 I1 implies I2, I3. He is going to purchase I1, I2, and I3. And I2, then I1 and I3. Then I3, then I1 and I2. So here, what is the meaning of this? So here we need only, this is one type of feature reduction also. So we need only three features, three attributes in the sense, three features for a is sufficient. That means these three features are strongly connected also. So now you have to see how you are going to find or what are the rules are needed for the next level. So initially we were fixed, our confident is, a confident is 60%. Now each and every rules you have to calculate the confident. So here I1, I2 implies I3. So here is a confident equal to support. You have to call this particular case, you have to calculate the confident. So confident equal to support of I1, I2, I3, because these are the items divided by support of the left side I1, I2. So you know that the support of I1 and I2, I3 is 3 by 4. Okay, support of is support of I1, I2, I3. You can see I1, I2, I3 combinations is 3. Okay, I1, I2, I3, you can go to the table. I1, I2, I3 is 3. And the support of I1 and I2, we'll see I1 and I2, the support is 4. So that's the reason I have written here 3 by 4 into 100. So for this particular role, the corresponding confident is 75. So that means, but our minimum confident is 60%, and here the 75 is greater than 60%. So this rule you have to take it. This rule you have to take it. Now we can go to the next rule. I1, I3 implies I2. So here again, you have to calculate the confidence of support of I1, I2, I3, that you already know that 3, and the support of I1, I3, we can look into that. What is the support of I1, I3? So here you can see that the support of I1 and I3 is again 3. So here it is 3 by 3 into 100. So that is effectively 100%. So confident is 100%. What is the meaning of that? Confident is 100%. Means if a one person is going to purchase item number 2 and item number 3, surely he is going to purchase item number 1. That much confident he is having. Okay, 100%. So our support, minimum support is confident is 60%. So this rule also you have to take it. Now the third one, I2, I3 implies I1. Again, I1, I2, I3 divided by the support of I2 and I3. That is also 75%. Now, such a way you have to calculate these 8 rules, and you have to check, okay, any rule, the value is less than 60%, then you have to throw that. But here we found that everywhere it is more than 60%, so you have to choose all rules. Otherwise, you can reduce some rules also. So this is the way you are reducing based on the support and confident. You are going to reduce the number of rules, and you can extract the information very easily using associate rule mining or a priori algorithm. So this is the basic concept behind in this a priori or associate rule mining. So here I can tell you, here we can say that C is the candidate item set of size K, L is the frequency item set size K, join step K is, so here it is effectively it's a two-step process. In algorithmically, this is a two-step process. The first step is called a join step, and next step is called a prune step. For a join step, Ck is generated by joining L of k minus 1 with itself. Prune step, any k minus 1 item set that is not frequent cannot be subset of a frequent k item set. Then what you have to do? Throw. So this is the corresponding pseudocode for a CK, L1 is the frequency items at 1 at a time, 2 at a time, 3 at a time, etc. For K equal to 1, 2, 5. That means there is no element in the worst case. Then increment K plus plus, CK plus 1 candidate generated from LK. You have to generate the candidates. For each transaction T in the database, do increment the count of all candidates in CK plus 1 that are contained in T. Then Li plus 1 candidates in Ci plus 1 with the minimum support return. So you have to club together. So this is the algorithm for associate rule mining, especially for a priori algorithm. Yeah. So now any doubt you have, you can ask me. After that, we'll go to the next algorithm. Any doubt from any side, please. It's not a complicated algorithm, I know that, but anyway, so you have any doubt or clarification, please, from any side. After that, we'll move to the next algorithm. Yeah, any doubt or clarifications, please? Okay, thank you. I saw the message. Okay, it's clear to everyone. That's what my understanding. This is a very simple algorithm, but this is one of the standard algorithms. Okay, yeah. So here in these algorithms, like you may have means the time computational complexity may be high. So you have to, maybe you may have a better algorithms or with a better strategies in the sense you are applying sampling or some other strategies are there. Based on those strategies, you can optimize this algorithm, a priori algorithm. Okay, we have a different strategy for optimizing this algorithm. Yeah. Now we will go to the next algorithm or next technique is called a collaborative filtering. So we will discuss this concept also for the next 20 minutes. So what exactly a collaborative filtering will do, I'll explain. Collaborative filtering is a most common technique used when it's come to building intelligent recommender systems. So this is related to recommendation systems. What is the meaning of a recommendation system? Recommendation system in the sense, for example, you are watching a movie. It's a recommendation system. So others will recommend whether that movie is good or bad based on the feedback. And you are going to purchase something from Amazon. It's a recommendation system. So here, collaborative filtering is a one type of a recommendation system. Most common technique used when it's come to building intelligent recommender system that can learn to give better recommendation as more information about user is collected. Amazon, YouTube, Netflix use collaborative filtering as a part of their sophisticated recommendation system. That means here sometimes here recommendation systems, how they are getting the input. Okay, so maybe sometimes just will give 0, 1 or something like a stars numerical. Sometimes you'll give some comments, so you have to extract those comments and you have to give a feedback. And another aspect of recommendation system is like, okay, they can analyze the users. Okay, for example, they are selling some product, then user 1 and user 2, whether the choice or test of user 1 and the user 1 and user 2 is similar, or this user 1 and user 2 are totally dissimilar. So interest, test, everything they can analysis based on the collaborative filtering technique. So that is the importance of collaborative filtering. So that is the reason, so most of the online traders or online companies, they have a collaborative filtering techniques. Yeah. Amazon, they have a collaborative, YouTube also they have a collaborative. So we will see how a collaborative filtering technique will work. This techniques to build recommenders that give suggestions to a user on the basis of the likes and the dislike of the similar users. Okay, like and a dislike. So you people also will do the same. Whatever items we will purchase through the Amazons, they'll ask us to give some reviews. So we'll give some reviews. So that review may be direct review, like, okay, you are giving some stars. So 1 star, 2 star, 3 star, 4 star, 5 star, etc. So that is a count 1, 2, 3, 4, 5. Another way is like, okay, you will give some comments. Okay, so that comments also they have to analysis. So here we have a direct and a indirect type of this one inputs for a recommendation systems that can filter out items that a user might like on the basis of reactions by similar users. Yeah. Searching a large group of people and finding a smaller set of users with a taste similar to a particular user. So here, even they can group together for the similar group, similar people, and even they want to send any messages or whatever advertisement they need to send. So they can send only they will send only to those people for a similar interest. Other people they can avoid, and that can filter out items that a user might like on basis of reaction by similar user. Searching a large group of people and finding a smaller set of users with a taste similar to particular user. This is what they are performing. They have a very huge amount of data set. Okay, so they have to perform some analysis on data set and they have to see whether similar groups are present or not. Then it look at the items they like and combine them to create rank list of suggestions. Okay, so based on that, yeah. Now I'll tell you how they are going to generate the data set. This is one way they can generate a data set. Now just assume that this is a very small data set. Here containing a set of items. So items are item number 1, item number 2, item number 3, item number 4, and item number 5. And a set of user, we have a user 1, user 2, user 3, user 4, user 5, etc. Whatever may be the number of users. And each and every users, sometimes they'll give a review for some particular item, sometimes they won't give a review. So here we can see that in user 1, item number 5, and we have a scale also here. Scale in the sense like, okay, 1 to 5, like a 1 star, 2 star, 3 star, 4 star, 5 star, etc. So that is called a scale. So here we can see that for a user 1, it's given 5 star to item number 1. Item number 2 is not reviewed. And item number 3, he reviewed and has given a very nice feedback, it's 4. Item number 4, he don't like, so he was given, it's a rank as this is a star, 1 star. And item number 5, he is not reviewed. Similar way for a user 2, item number 1, no review. Item number 3, he was given 3 star. Item number 3, no review. Item number 4, he was given 3. And item number 4, it is not reviewed. Q3, user 3, item number 2, he was given a very low. Item number 3, he given a nice. Item number 4, he given nice. Item number 5, he given very low. Such a way, so here now you understood how you are going to generate the data set. This is the way you have to generate a data set. Now what is the real problem here? Like because whenever you are going to apply the algorithms, different types of algorithm, the real problem is it is going to generate a sparse matrix, because a lot of places zeros, that means they are not reviewed. So those places you have to put some zeros. So that is one issue with this. So containing a set of items and set of users who have reacted to some of the items. Reaction can be explicit. So here we have two different types of reactions. Normally, in our case also we have two different types of reactions. One reaction is like, okay, directly you will give a star, 1 star, 2 star, 3 star, etc. That is one type of reaction. And another type of reaction is like you will give some comments. So reaction can be explicit. So rating on a scale of 1 to 5, like or dislike. Reaction may be implicit. So two different types of reactions are there. One is called a explicit reaction and another one is called a implicit reaction. Implicit reaction, viewing an items, adding to it to a wish list the time spent on an article. These are some examples of a implicit reaction. For example, you saw some items and you are liking that item, automatically you are putting that into cart in Amazon or maybe any other website. So that is one type of implicit reaction. So we have a implicit reaction and an explicit reaction. I think it's clear to everyone. What is the meaning of implicit? How we are going to generate the data? Implicit reactions, it's very easy because we are giving a range. And explicit reactions, I think we'll get some unstructured or semi-structured data. From that, you have to make it as a structured one. Attributes, you have to extract the attributes like our spam filtering type of techniques. Then you have to generate a data set. Okay, so this is the way you can generate data set. So here we can generate the data set in two ways. One is called with a explicit, that means it's based on the directly you are taking the ratings, and those ratings it's you are directly forming a matrix and generating it data set. That is the explicit. And implicit is like, okay, you will give some comments, or sometimes you will put it in your cart, or you are searching, you are spending more time on that. Depend. So a lot of parameters are there. Based on that, you are extract the features, and that feature set you are going to give to the algorithms. So these are the two way you can generate the data set for a generating the data set for a collaborate filtering. Yeah. Now, two way you can generate the data set for collaborative filtering. So now what exactly you have to do? So here, now you have to measure the similarity. Okay, measure the similarity. So this similarity is going to tell you that these two users have a same test, or this user have a different test, or something like that. Now I can tell you here, you just assume that we have four different types of movies. Movie 1, movie 2, movie 3, and movie 4. Four movies. And we have different users also. We are assuming that four users. User 1, user 2, user 3, and user 4. Now we are going to check whether this user 1 and user 2, or user 1 and user 3, or user 2 and user 3, or whatever may be, those two users having the similar behavior, similar test, or they have a different test or not. So now we can see that for a movie 1, user 1, he liked movie 1 because he has given 5 star, and user 2, so if movie 1 he given 4 star. That means this user 1 and user 2 is, their test is similar in terms of movie 1. In movie 2, the user 1 he is not reviewed, but sorry, user 1 he was given a nice score, that is 4, and this user 2 is not reviewed. Movie 3, user 1 is not reviewed, but user 2 is given an average score of 3. And for a movie 4, the user 1 is given 5 and the user 2 is not reviewed. And we can see that for a user 3, first movie is not reviewed, second movie is reviewed but is given a very low score, and third review is not reviewed, and fourth movie he reviewed but he was given very minimal score. And a user 4 is reviewed 1, he given very minimal score. Review 2 also given minimal 2 score. Movie 3 he is not reviewed. Movie 4 also he is reviewed. So now what you understood? What is the basic understanding of the system? Rather than going for the algorithm, or rather than going for the mathematical part of this, the basic understanding is very clear that user 1 and user 2, they may have some similar test, and user 3 and user 4, they may have some similar test. It's not exactly, we are not going to define, but similar tests are there based on the movie 1 for review from user 1 and user 2. For example, for a user 3 and user 4, based on movie 2, we can say that they have some similar tests. So this we are going to analysis. Yeah. So here we can see that now what if we inferred? User 1 and user 2 give nearly similar rating to the movie. So we can conclude that movie 3 is also going to be averagely likely by user 1, but movie 4 will be a good recommendation to user 2. Like this, we can also see that there are users who have different choices, like user 1 and user 3 are opposite to each other. The reason is like, okay, the user 1 and user 3, they have a different taste. Now, one can see that user 3 and user 4 have a common interest in the movie. On that basis, we can say that movie 4 is also going to dislike by the user 4. This is a collaborative filtering. We recommend users items which are likely liked by the user or similar interest domain. So this is one type of a collaborative filtering. This is one type of a recommendation system also. This is not an exact matching, but we can see that we can see some trends, or we can see some behavior, similarity, okay, similarity among the users. Based on that, you can recommend it. So that is a basic recommendation systems. Yeah, I think this is clear to you. Now we'll go to the depth of recommendation system, or collaborative filtering. So now, how we are going to measure, the similarities. So because it's whatever we done here, this is only a look from the look. We done some analysis and we concluded that okay, user 1 and user 3, or user 1 and user 2 are similar, and user 1 and user 3 are dissimilar, or user 1 and user 4 are dissimilar. So we concluded based on some look, but we need some measures, and that measure should say that okay, these two systems, okay, are similar, or these two systems are dissimilar. So what are the measures for a collaborative filtering? So that we have to discuss. So here, one simple measure you are familiar with this is called a cosine distance, cosine similarities. Find out the users with a similar interest. Large cosine implies that there is a smaller angle between two users. Hence, they have a similar interest. Apply the cosine distance between two users in the utility matrix, and we can also give the zero value to all the unfilled columns to make calculation easy. If we get similar cosine, then there will be a large distance between the user, and if the cosine is smaller cosine, then there will be a large distance between the user. And if the cosine is larger, then we have a small angle between the user, and we can recommend them similar things. So this is one measure. Like a lot of measures are there. It's like a very simple measure is called a cosine distance. So here I'll repeat. Apply the cosine distance or cosine similarity between two users in the utility matrix. And we can also give the zeros. That means those the values are not present, there we can give 0. Values to all unfilled columns to make the calculation easy. If we get a smaller cosine, then there will be larger distance between the user. And if the cosine is larger, then we have a smaller angle. Because cosine, no, like cosine 0 is, and cosine 1, okay, cosine 1 is, yeah, and cosine 0. So what is the value of cosine 0? What is the value of cosine 90? Okay, cos 90. So that you can think, okay. So the based on that you can think, okay, then that will be larger and that will be smaller than what will happen. Okay. So based on that we can give a recommendation. So I'll explain. Now just assume that this is the data set. In this data set consists of 6 users and 6 items. So that item may be like a film or whatever may be. And here you can see that these are the users. Okay, user 0, user 1, user 2, user 3 items. And item 0, 1, 2, 3, 4, 5, and user 0, user 1, etc. Now what you are going to do for a user 0, he was given, it's just assume that the scale of 10 here. Scale of 10. That means, okay, 0 means dislike, 10 means it's the most liking. This items he has given 3, second item 7, third item 4, fourth item, sorry, yeah, this one 9 is a 9 and this is 5, like a star or whatever maybe. Similar way for a user 2, 3, 4, 5, etc. were given 1, 2, 3, etc. They were given different rating for a different items. Now what you have to do? You have to check whether user 1, 0 and user 1 are similar. What about their behavior? And user 2 and user 1 and 2 is similar. 0 and 2 is similar. And 0 and 3 is similar. 1 and 2 is similar. 1 and 3 is similar. 2 and 3 is similar, etc. So for that, what you have to do? You can take, for example, you are going to consider this 0 and 1. 0 and 1. Then you have to calculate the cosine similarity. So here we can see that you can multiply a zeros and ones. So here it is 3 into 7 plus 7 into 0 plus 7 into 5 plus 5 into 6 plus 5 into 8 plus 7 into 7. So that value is called as sigma I equal to 1 to n of AIBI. AIBI. So that value. Now we can take 3 square plus 7 square plus 7 square plus 5 square plus 5 square plus 7 square. So that value is called the root of I equal to 1 to n of ai square. Similarly, you can calculate the value of bi also. Okay, root of bi square also. So this will give a value. Okay, this will give a value because it's a cos theta. So maybe it's normally it will give 0 to 1 because there is no negative here, 0 to 1. So based on that, we can say that that's what here I was mentioned. Apply cosine distance between two users in the utility matrix, and we can also give a zero value. If we get a cosine similarity, smaller cosine, okay, smaller cosine, then we can say that smaller cosine because cos 0 is 1, cos 0 is 1, it's a smaller cosine, we can say that larger distance means angle is larger. So that information we will get is. This is the way you can calculate the cosine similarity, and you can say that user 0 and user 1 are similar, or user 1 and user 2 is similar, or user 2 and 3 similar, or 0, 3 similar, etc. Like such a way you can calculate the cosine similarity of each and every values. At last, you can conclude that these two users are similar or these two users are dissimilar. Based on that, we can make the recommendation. So this is the one way. This is the one way you can calculate the similarity between this, and you can apply collaborative filtering on that. Now, another measure, lot of measures are there. Here I'm going to discuss only two measures. Another measure is called a Pearson correlation coefficient. Okay, called Pearson correlation coefficient you can calculate. And so here we can see that. Now again we are going to the previous table. So this is 0 and this is 1. Now what you are going to do? You are going to calculate the average. Means 3 plus 7 plus 7 plus 5 plus 5 plus 7 divided by 6. What is average of that x value? Average of y value. So that is 7 plus 0 plus 5 plus 6 plus 8 plus 7. Average of that y bar. So that is x bar and y bar here. So here we can see that x bar and y bar. Okay. Then you are going to subtract that value from each and every xi. x1 minus x0 minus x bar, x1 minus x bar, x2 minus x bar, etc. up to x5 minus x bar. Similar way, y also you can calculate. And here it is a standard deviation of x and standard deviation of y. Using this formula, you will get the correlation coefficient. Sometimes you may get a correlation coefficient is 0. Sometimes you may get a correlation coefficient as -1. This one, sorry, 1. Okay, so within the range, you can say that whether this x and y are highly correlated or a non-correlated. Based on that, you can say that user 1 and user 2 or user 1 and user 3, whatever may be, they have the similar items. That means whatever item you are going to recommend for this user 1, the same item you are going to recommend for this user 2, etc. So this is the way the collaborative filtering is used. So here, so you can see that items, okay, different items are there. So each and every items, okay, whether these two items are similar or these two items are dissimilar. So for today's class, we have suggested me to take two different concepts. First concept is called associate rule mining, and another next concept is called collaborative filtering. So we were discussed associate rule mining is based on market analysis, and this associate rule mining is based on market analysis, and collaborative filtering is purely based on our recommendation systems. So these are the two concepts. Okay, so now, so with this I'm going to conclude today's section. 10 minutes I'll give for a clear doubt clearance. Okay, yeah, thank you, that's all. Yeah, any doubt or clarification, please? So we were discussed two different concepts. One concept is called a priori algorithms, or and the next one is called a collaborative filtering. Yeah. So you have any doubt or clarification, you can ask me now. Yeah. Any doubt or clarification, please?
Sir, yes, sir. Sir,
Okay.
thank you.
Thank
Sir,
you. Thank you.